Okay, so members, today we are going to see the difference between a chord, a focal chord, and a latus rectum. But please don't forget to subscribe to my channel. Now, the idea is a chord is a line that joins two ends of a parabola. So if you have a parabola like this, if we have a line that joins these two ends, is what we call a chord. Now, just that, it means it's a chord. Now, what about a focal chord? Now, it's also a line that joins two ends of a parabola, but for it passes through a focus. So the focus of this parabola is here. So if this chord is passing through the focus, that's why we call it a focal chord. The focus, hence the name focal chord. What about latus rectum? Latus rectum now, for it is a focal chord. First of all, it passes through the focus and joins two ends of a parabola. But for it, it's perpendicular to this horizontal. So alright, latus rectum is a chord that passes through the focus and is perpendicular to this horizontal. Now, because it's perpendicular to the horizontal, we can easily get its length. How? We know that because it passes through the focus, always a focus is at a0. So, meaning that the x values are always going to be the same because it's perpendicular. So that line is line x equaling to a. So that's why this is a, and this is a. Now, what about the value of y? Because it passes through the focus, it means when a, you see that x is equal to a. When I put my x here, I have this, and I get the square root, I have plus or minus. So, because this is up, this one is going to be 2a, and this one is negative 2a. Now to get the length, we shall say 2a minus this one, negative 2a. And so the length of the latus rectum orange is L equaling 4 times a, where a is this coefficient here. Now, how do we get the equation of a chord? Remember, chord is a line. Always know that because to get the equation of a line, we need the point where it passes and its gradient. Now, we want now to find the equation of a chord that joins the points P and Q of a parabola. This. Now we know that it passes through these 2 points. So we have already the points, so we are missing the gradient. But you can get the gradient. Why? Because we know that this line is passing through these 2 points. So we can get the gradient by saying changing y over changing x. So the gradient of PQ, it will be now, I will say, this one is my y2, y1, x2, x1, so I say 2ap minus 2aq over ap squared minus aq squared. So that for me, a 2a is common, so if I factorize out 2a, I'll be adding 2a into p minus q, then down a is common into p squared minus q squared. So from there, we start this a goes away. So up I have 2 into p minus q. Then down, so this is the difference of the squares, which will be p minus q, then p plus q. So this goes away with this, and so now I'll be adding 2 over p plus q as my gradient of pq. This is our gradient of pq, of that line pq. Now we have the gradient, so we just substitute in our line that already if it's a line is y, a point, then the gradient, then x minus the x coordinate of the point where that line passes. But I have seen it's passing through the point p, which is ap squared comma to ap. So this is the x coordinate one, and this is the y coordinate. So putting them here, I have now y minus. The gradient is here as into now x minus x1, which is ap squared. So you cross multiply like this. So we are in this and this, y into, then minus p plus q equaling to, this side if you open brackets we have 2x, then minus 2ap squared. So that's open brackets and we see we have y into, then minus we have 2ap squared, then we have minus 2ap PQ equaling 2x minus 2AP squared. And you see that this goes away with this. When I take this the other side, I have now y p plus q equaling to 2x now plus 2apq. And this remembers the equation of a chord. So this is the equation of a chord always to a parabola. Now, we want to see what is the condition for a focal chord. We said a focal chord for it to pass a focus, but still it's a chord, meaning that this is going to be still the equation. So from here, our equation is going to be y into p plus q, because they are the same, equaling to 2x, then plus 2a pq. But because it's passing through the focus, always our focus is at a comma 0. Meaning that from 0, my x is a and my y is 0. So now if I put them here, I'll be having 0 into equaling to 2a plus 2a pq. So you see that now when I take this side, I have 2a pq equaling to negative 2a. When I take this side, this one remains 2a pq. This comes to the side, divide through by this, that now my pq is negative 1. And always remember, this is the condition for a focal chord. The condition for chord B focal chord. Now, that's all. So whenever I say this condition is true, it means that what you had was a focal chord. Now, we said you can get the length of the latus rectum. How? Examples are here. Find the length of the latus rectum of, they give you this now. Now when they give you this, you know that our latus rectum, the length is 4a. You need a. Now we just compare with the general, y squared equaling to a plus b. From here, if you compare, you start your 4a is 16 and your a is 4. Meaning that now the length will be 4a, which will be 4 times 4, which is 16. As simple as that. When you come to this, you just compare. Y squared is equaling to 4ax. From here, if you compare, start your 4a is equaling to 12 and your a is 3. So the length we said is 4a. Now your a is 3, which will be 4 and 3, which is 12. Always remember, we don't even waste time because this one is going to give you the length of the latus rectum. These are units, and here we have units. So you see the area here is 4 units. So members, that's the difference between a chord, a focal chord, and latus rectum. Don't forget to subscribe to the channel. I wish you the best.